Hello everybody, today we're going to talk about zeros, factors, and solutions. So we're going to let f of x be this polynomial right here. And the following statements are equivalent. K is a zero of the polynomial function f. X minus k is a factor of the polynomial f of x. And k is a solution of the polynomial equation f of x equals 0. All those things are really the same thing. So we can take a look at that with an example like this. So consider the function f of x equals x cubed minus x squared minus 4x plus 4. Find the factors, zeros, and solutions. Okay. So the first thing we want to do is factor it. That's always the first thing you're going to find. So if I look at this, this looks like we can factor it by grouping. So if I look at these two right here and these two right here, I can factor an x squared out of here. And that would leave me with x minus 1. And then I'm going to factor a negative 4 out of here. And that's going to leave me with a positive x here and a negative 1 there. Now, I want to make sure these two are the same thing. I got to get the same thing out of both pieces of this. Okay, and the reason for that is because now I can factor the x minus 1 out, and I'm left with x squared minus 4. Okay, and then that's a difference of two perfect squares, so I can factor it to x minus 2, x plus 2. So there's my factors. Okay, I have factored that as far as it's going to go. Okay, it's got 3 factors because it's degree 3. I got them all. They're all integers. So if I was factoring over the integers, I couldn't go any further than this. Okay, now the zeros. Okay, what's going to make these zeros? Because remember, the zeros are when. Here, let's take this, move it over here. The zeros are when this equation equals 0, right? So I've got a times b times c equals 0. That means that either a, b, or c has to be 0. So that means that x is going to be 1 right here. That means that x would be 2 right here. And that would mean x is negative 2 right there. Okay? So actually, those are the solutions to this thing. Okay, so there's my solutions. And then my zeros are going to be the points. So this is the point 1, 0. This is the point 2, 0. And this is the point negative 2, 0. Okay, those are the zeros. Those are all equivalent things. My zeros, my solutions, and my factors. Okay? So, that one was pretty easy. They're not always easy. Now, this leads us to the fundamental theorem of algebra, which was created by maybe the greatest mathematician of all time, certainly of his time, was Carl Friedrich Gauss. Okay? It says, counting complex and repeated solutions, an nth degree polynomial equation has exactly n solutions. So when I look here, this is 3rd degree. That means it has to have 3 solutions. Sometimes it's not obvious what they are, but it must have 3. They can be integers, they can be rational, they can be real, or they can be complex. Okay? So, how many solutions does each polynomial have? All right, so let's start with this one. X minus 4 is 0. This is a 1st degree polynomial. That means that it's going to have 1 solution. And pretty easy to solve. I just have to simply add 4 to both sides here, and I get x is 4. And I'm done. 1 solution. Okay, next. This one is 2nd degree polynomial. It's going to have 2 solutions. This one I'm going to do by factoring. I'm going to put an x here and an x here, 3 here and a 3 here, and a negative and a negative. Okay, not too hard to factor. and then that means that x is going to be 3, and x is also going to be 3. Now, this would, how many solutions does it have? Well, you'd say, well, it's got 3 and 3, so it only has one solution. Well, yes and no. It has, we say that it has a solution of 3 with a multiplicity of 2, which means that answer occurs twice. Okay, so it has two solutions, they're just the same. Okay, now this one, here, degree 3 is going to have 3 solutions. So we factor it. The first thing I would do is look at this and go, hey, you know what? That's got an x in both terms, so I can factor out the x. I get x squared plus 4 equals 0. Now this would have been really easy if this was a negative, because we'd have a difference of two perfect squares. We don't, which means it's not going to have real solutions. Okay, I can still factor this, so I get x, and I'm going to get x minus 2i plus, or x plus 2i. All right, so what's going to make this 0? 0. This is going to be 2i, and that's going to be negative 2i. So it has 3 solutions. 2 of them are imaginary. Now, here's something to keep in mind. If you get an imaginary answer, there will be another imaginary answer. There always has to be an even number of imaginary answers. So if you've got 1, you've got 2. If you've got 3, you've got 4. If you've got 5, you've got 6. Okay, and they have to be what's called conjugates of each other. So if one is 2i, the other one has to be negative 2i. Okay, if you had one that came out to be 3 minus 4i, then the other one would be 3 plus 4i. They come in pairs like that, okay? Now you don't have to have imaginary solutions, but a lot of times you do, so, but just remember, they come in pairs. If you've got 1, you've got more than 1, okay? All right, what about this one? Well, this is a difference of two perfect squares, so I can make this x squared minus 1 times x squared plus 1. And then that's a difference of two perfect squares, so that's x minus 1, x plus 1. This is a sum of two perfect squares, which means it's going to be imaginary, but it's going to look like this. So it's going to be x minus I, x plus I. So you can see I'm going to get imaginary answers here, and there's 2 of them. Okay, so here I get x is 1, here I get x is negative 1, here I get x is I, and here I get x is negative I. Notice they're a conjugate pair again. One is positive, one's negative. I've got 4 solutions. I've got degree 4. I've found them all. Okay, if you get something that's degree 4 and you only find 2 solutions, you got to keep looking because there's 2 more somewhere. A polynomial of degree n has exactly n linear factors. So what that says is it's kind of like this one. Okay, it's degree 4. These are linear factors when you get x plus or minus something. Okay, so in degree 4, it's got 4 linear factors. This was degree 3, it's got 3 linear factors. This was degree 1, it has 1 linear factor, and this was degree 2, it has 2 linear factors. Okay, so if I have an x to the 5th, there's 5 linear factors that it will factor to. Okay, let's look at this one. This is a nasty one. F of x is x to the 5th plus x to the 3rd plus 2x squared minus 12x plus 8. Write it as a product of linear factors and list all of its zeros. Okay, so this thing is going to have 5 linear factors. I just got to find out what they are. So I'm going to have to do this. I'm going to have to do this by taking the factors of 8, which are plus or minus 1, 2, 4, and 8. And that's divided by plus or minus 1. Okay, so what you always want to do is you always want to get the rational ones out first. Okay, So this is how I find my rational factors, remember? And I'm going to use some synthetic division. So I've got 1. I don't have an x to the 4th term, so I remember to put your 0 in there. I've got a 1 for the x to the 3rd. I've got a 2 for the x squared. I've got a negative 12 for x, and I've got an 8 for the constant. Drop my 1 down here, and hopefully we can knock this out pretty quick. Let's try a 2. Okay, so 2 times 2 would be, 2 times 1 would be 2. That's 2. 2 times 2 is 4. That would be 5. That's 10. That would be 12. 24. That would be 12. Nope, too big. Okay, so that one didn't work. So we'd start over, right? Let's try 1. Okay. 1 times 1 is 1. That's 1. 1 times 1 is 1. That's 2. 1 times 2 is 2. That's 4. 1 times 4 is 4. That's negative 8. And 1 times negative 8 is negative 8. That's 0. Okay, that's helpful. You know, I might be able to get another 1 out of this one, it looks like. After a while, you kind of get good at figuring out what's coming out of these things. So let's try 1 again. 1 times 1 is 1, that's 2. 1 times 2 is 2, that's 4. 1 times 4 is 4, that's 8. 1 times 8 is 8, that's 0. Okay. So 1 came out of there twice. All right, see how they're all positive? That means that the only thing coming out of there now is going to be negative. Okay, so we'll do another one. And we'll try a negative this time. How about a negative 2? Negative 2 times 1 is negative 2, which you add up, that's 0. Negative 2 times 0 is 0, that gives me 4. Negative 2 times 4 is negative 8, which is 0. So this has been pretty easy so far. Now, remember this was an x to the 5th. That makes this an x to the 4th, an x to the 3rd. This is an x squared. So this is x squared, no x, plus 4. Okay, I'm not going to be able to factor any more out of there. So what I need to do now is I need to factor this. I'm going to get an x and an x. This is a sum of two perfect squares, so this is going to be a 2i and a negative 2i. Okay, so this will give me x will be 2i, and this will give me x will be negative 2i. And now I've got 5 solutions. So what are my solutions? X is going to be plus or minus 2i. It's going to be negative 2. And it's going to be 1 with multiplicity of 2. Because the 1 occurs twice. Okay, so remember I was supposed to have 5 solutions. I've got 2, 3, 4, 5. Okay, I got them all. There is no more. If I was going to write this as a, oh yeah, I need to still write it as a product of linear factors. I got all the zeros, that's these. Okay, if I was going to write it as a product of linear factors, okay, so this would be, remember it's always the opposite of this, so it would be x minus 1 times x minus 1 times x plus 2. And then with my i's, I've got 1 of each, so it's going to be x minus 2i, x plus 2i. So there's my product of linear factors, and of course there's 5 of them because it's degree 5. Okay, so here's my product of linear factors, and all of the zeros are right there. Okay? Alrighty then. Here's your assignment for the day. Shouldn't be too difficult. Enjoy that. I'll talk to you later.